Hello students, welcome back to Chemistry Online Classes. In the last class, we were discussed chemical properties of acids. Today, we are continuing with bases and its physical properties and chemical properties. So, physical properties, I will just say once because we have already discussed in the first session. As you know that bases have bitter in taste, they will turn the red litmus into blue litmus. Okay, bases are dissociates to give OH minus. Acids are dissociates to give H plus ions. Bases are dissociates in water and produce hydroxide ion, OH minus ions. And the next point, all metal hydroxides like sodium hydroxide, potassium hydroxide, etc. are bases. These are the strong bases. Okay, and the metal oxides are basic in nature. The reason you have already discussed in the earlier session. Metal oxides are basic in nature because metal oxides dissolved in water to produce base. So metal hydroxides and metal oxides are bases, not the point. Okay, and last point, bases which are soluble in water are called alkalis. These are the two bases. These two bases will dissociate in water. That is why they are called alkalis. All bases are not soluble in water. Only those bases like strong bases dissociates in water and form OH minus ions. So note the point, all alkalis are bases, no doubt. Because these two are alkalis. Why? They dissociates in water and form OH minus ions. Okay, but all bases are not alkali. Why? Rest bases are not dissolved in water. Only the strong metal hydroxide bases will dissociate in water and they form hydroxide ion. That is why all alkalis are bases but all bases are not alkalis. Now the first chemical property, reaction of base with metal and produce salt and hydrogen gas. The same reaction you have learned in the chemical property of acids also. Like same way, here base also reacts with metals and produce salt and hydrogen gas. So, all metals do not react with base. The metals like zinc and aluminium reacts with base and form the corresponding metal salt and hydrogen gas is produced. Okay, so I'll write one example. Sodium hydroxide base reacts with the zinc. Here the product is a complex salt because this zinc is not capable to replace sodium since it is highly reactive. So that it makes a complex salt. The salt is called sodium zincate. This salt, this complex salt is known as sodium zincate plus hydrogen gas is produced. Okay, so zinc reacts with sodium hydroxide base to form sodium zincate salt and hydrogen gas. So what happens if aluminium reacts with sodium hydroxide? Let's see. Sodium hydroxide reacts with the aluminium to form sodium aluminate. Here we have taken aluminium. So instead of zincate, it forms sodium aluminate. How we will write? NaAlO2. Sodium aluminate plus hydrogen gas. This is gas. The next property of base, reaction of bases with non-metal oxides. What are non-metal oxides? The sulfur dioxide gas is a non-metal oxide which has been formed. A sulfur reacts with oxygen to form sulfur oxide. Since sulfur is a non-metal, the oxide is non-metal oxide. And carbon combines with oxygen to form carbon dioxide. Carbon is a non-metal and it combines with oxygen to form carbon dioxide. Take any of the non-metal oxide, either sulfur dioxide or carbon dioxide. Take any one of the gas. Okay, and dissolved in water, you will get carbon dioxide dissolved in water, you will get carbonic acid, H2CO3. Sulfur dioxide dissolved in water to form sulfuric acid. So remember the point, non-metal oxides dissolved in water and form acids. So what is the nature of this non-metal oxide? Since it produces acids, these two non-metals are acidic in nature, because these non-metals reacts with water to form acids. So the nature of non-metal is acidic. So we have already discussed metal oxides are basic in nature. So that metal oxide reacts with acids. So non-metal oxides are acidic in nature. So non-metal oxides reacts with the bases. Okay. So what happens? This non-metal, if you take carbon dioxide, reacts with a base. Suppose calcium hydroxide base. So what is the product? Yes, it will form calcium carbonate and water. And water. Okay, so generally you can write non-metal oxide reacts with the base to form salt plus water. Okay, remember the general equation. There non-metal oxides, here non-metal oxides reacts with base to form salt and water. Metal oxide reacts with acid to form the same product. Since the nature is entirely different, so that it can be reacted accordingly. Okay. Okay. Finding out the electrical conduction of acid solution in water. For that, take 100 ml of beaker with 50 ml of water and 3 drops of dilute sulfuric acid. This is the electrolyte. After that, cover it with a cork and fix 2 nails. So, one end of the nail is connected to the positive terminal of the battery, that is called anode. The other end of the nail is connected to the negative end of the battery, that is cathode. Okay. After that, a bulb is being fixed and an ammeter also fixed. This is ammeter. So, after some times, after the arrangement, what you have to do is just switch on the battery. By the time you switch on the battery, you can see that the bulb starts glows and the ammeter shows deflection. Why the bulb glows and why the ammeter shows deflection? Because here you can see in the water you have added 3 drops of dilute sulfuric acid. Sulfuric acid dissociates in water and form H plus ion or H3O plus ion. Okay, so it will produce H plus ion. So whenever there is a presence of ions, it conducts electricity. Here H plus ions are there in the solution excess. So that it shows acidic character. The ions are present in the solution means it starts to conduct electricity, and the bulb shows ammeter shows deflection and bulb glows. Okay, what happens when you pass electricity? When you pass electricity, here you can see sulfuric acid is there. Okay, that will produce H plus ion like this. So H plus ions are continuously produces. So by the time the H plus ion is moved to the cathode, since H plus is positive, it will move to the cathode. And when it reaches to the cathode, this hydrogen will take, this H plus will take one electron and form H, and other H plus will take one electron and form H. So H plus H will give you H2, hydrogen gas is produced in the cathode. Not the point. H plus ion, hydrogen ion cannot exist singly, that will move on to the cathode. From the cathode, it will take one electron and form hydrogen gas in the cathode. Okay, so whenever there is a ion, whenever there is a H plus ion or H3O plus, it conducts electricity. So let me ask you a question. Glucose is C6H12O6. Okay, glucose, and after that alcohol, CH3CH2OH. This is alcohol. Let me ask you a question. Will it conduct electricity instead of this sulfuric acid solution? If you use this solution or if you use this solution, will it conduct electricity? No, it never conducts electricity. You can ask a question, since hydrogen is present in both, why they don't conduct electricity? Because these two compounds are covalent compounds which does not dissociates in water. It does not dissociates in water and it could not produce H plus ion. It does not have, this does not have a capacity to decompose in water and which never produce H plus ions. So that it never shows acidic character. It never shows acidic character. So that only acids and bases conduct electricity in the water medium. If in the place of dilute sulfuric acid, if you use base, it will produce OH minus ion. That also will be a good conductor. Bulb will glow. Not the point. Only H plus ions or OH minus ions will be, responsible for the conduction of electricity. Okay, H plus ion will be showing the acidic character. Then the bulb will glow, and any other solution like organic solution like alcohol, etc. never show acidic character. Okay? Okay, students. Now let's understand the behavior of an acid and base in aqueous solution. For that, here you can see activity 2.9 in your textbook. Take a dry test tube and add some sodium chloride salt. To the sides of the test tube, add a few drops of concentrated sulfuric acid. So after that, you can see a dry HCl gas is produced. After the reaction, you can see that HCl gas is produced. Test the presence of acid by using a litmus paper. First, you check it with a dry litmus paper. That time, you cannot see any color change. But after some times, you keep a wet litmus paper over here. You can see the blue litmus paper turns red. Why the acidity shows only in the aqueous medium? Why the dry litmus paper does not show any changes? The point is that here the hydrochloric acid in the gaseous form is present. The HCl will produce H plus and Cl minus only in the water medium. Okay, this water is required to pull the H plus and Cl minus. In the absence of water medium, it does not produce H plus and Cl minus. Okay, this reaction is possible. This H plus ion is produced only in the presence of water. In the absence of water, this is not possible. So that blue litmus paper never turns to red litmus paper. But when you keep a wet litmus paper, that wet litmus paper turns to, wet blue litmus paper turns to red litmus paper. Okay? Like same way, base also. Sodium hydroxide is produced Na plus and OH minus only in the presence of water medium. In the absence of medium, it never produces OH minus ions. In the absence of H plus water, it never produces H plus ions. So remember the point, acids and bases show their behavior only in the aqueous medium. The point is very important. In the absence of water, it never produces ions, it never show any characteristics of acids as well as bases. Okay. Now let's go back to the previous class. There we have discussed some chemical properties of acids. Here I will show you some experiment based on the chemical properties of acids. For this activity 2.3, which is there in your textbook, a metal reacts with acid. Here we have taken a conical flask, a zinc metal. Okay, so take a zinc metal you can see in the watch glass. Okay, this is the activity 2.3 in your textbook, page number 19. Okay, so this is the setup. Okay, inside the conical flask we are doing the experiment. After all, we have connected a tube in the soap solution. Okay, and finally let's observe what you can see here. Okay, now take the conical flask and add the zinc metal inside the conical flask, and you take dilute sulfuric acid. Dilute sulfuric acid you have to add to the conical flask. When you add, you can see that a gas is coming out. Okay, when you can see here a gas is coming out, you stopper it with a glass cork, a glass tube. You have to connect it to the water first. Now you can see bubbles are coming. So after that, just pour it to the soap solution. Can you see the bubbles are formed here? Yes, the gas, it is passed through the glass tubes and finally it is reaches to the soap solution. The bubbles are formed. The bubbles are the hydrogen gas. The zinc metal reacts with the dilute sulfuric acid and form hydrogen gas. Okay, now the presence of hydrogen can be tested by using a burnt matchstick. So what happens when a metal carbonate or metal bicarbonates reacts with dilute acids? You have already learned that a sodium carbonate salt, it's a metal carbonate, okay, reacts with a dilute hydrochloric acid. Okay, now look at the bottom of the test tube carefully. Okay, using a spatula, take sodium carbonate salt in a test tube. Okay, after adding sodium carbonate salt, you have to add dilute hydrochloric acid. Look at the bottom of the test tube carefully. When you add dilute hydrochloric acid, look at the bottom. Okay, you can see that a brisk effervescence is coming. What is meant by brisk effervescence? Yes, this is the brisk effervescence. Okay, this is the brisk effervescence, that is carbon dioxide gas. Okay, this you can see that something is coming on the top. This is the brisk effervescence carbon dioxide gas. So the presence of this carbon dioxide gas can be tested. We know that carbon dioxide gas is a fire extinguisher. For that, let's check whether it will extinguish fire or not. Okay, again do the same experiment. Okay, and the gas which is formed is to connect through a gas tube, and you can keep a candle over there. Okay, when you add hydrochloric acid to the sodium carbonate, it will produce carbon dioxide. It will extinguish the fire. Look at here. The fire is extinguished because the gas which is formed is carbon dioxide. Okay. Now let's test the presence of carbon dioxide using lime water. Lime water is calcium hydroxide solution. Okay, so take calcium hydroxide solution, and what you have to do is produce same carbon dioxide. Okay, and look at here. Okay, carbon dioxide gas is formed when you add hydrochloric acid. Yes, just close the lid and pass this carbon dioxide to lime water. Okay, look at the lime water. Yes, the lime water starts to turn milky. This is carbon dioxide gas. The lime water is slowly turns milky. Look at here. Yes, what you can confirms? The gas which is formed is carbon dioxide. So the carbon dioxide turns to lime water, its milkiness, because this is calcium carbonate is forming there. Okay.